Thanks for joining, Eric. We're here at SOSV Climate Tech Summit. And the focus of the summit had me thinking about how electric vertical takeoff and landing aircraft companies have positioned themselves over the last few years. And I'm wondering if from the beginning, was commercializing sustainable air travel the starting point for Joby when it was founded in 2009, or was there another underlying mission?
Yeah, thanks, Kirsten, for chatting with me today. I think it's a really great question, and really, Joby was founded with this vision of creating a new type of transportation and some new type of mobility, letting people move through flight in their daily lives. And so, and really, the kind of catalyst for this was the technology that was developing and kind of the technology arc that had been improving over the last couple of decades. Really, I mean, people have tried to do personal air vehicles, vertical takeoff and landing in different ways in the past, and it's never really worked. And in some sense, it was really the technology change, which is that set of technologies that many people that are watching this are super familiar with, right? Batteries, high both power and energy density batteries, and the electronics that can actually harness that energy in the batteries and turn it into real work in high efficiency electric motors, and then all of the compute wrapped around that to make amazing machines possible. And that's why we have EVs. That's why we have the oodles of toys that my kids have in the playroom that have little batteries and do things. Essentially, it's that same set of technologies really that we saw in the early days as being having the potential to be applied to small aircraft in a new way, and ultimately, I think in the long arc of things, large aircraft. But right now, really focusing on small aircraft that can do this new mission of uh, vertical takeoff and landing, so mobility that is enabled by lower operating costs and much improved acoustics, which that technology allows. And that's really the driving force. And in some sense, then the fact that you have an all electric solution that works for that is like in some ways almost a side benefit. I think it becomes a primary, really important thing in terms of the economics, in terms of the utility, actually, because there's actually really interesting side effects of landing all electric things in terms of the kind of emissions profiles and where you can land as a result of that. But that's in some sense almost a benefit of this overall technology arc that enabled the mission that we were really going after.
I know acoustics has been a big part of it. So was that part of that early mission, or was it all about, hey, we want to solve this mobility issue, full stop? How do we do that? And then it started from there looking at flight and, like what is that origin mission for Joby?
Well, acoustics really can't be taken away from that mobility mission
Yeah.
in a lot of ways because we have vehicles, certified aircraft today called helicopters that can take off and land vertically and that can transport people. And it's just that they have an acoustic footprint that is kind of just the physics of how they operate. And that is something that I think inhibits the broad kind of like a larger market growth that could happen, even outside of the economics. I think economics
Yeah.
also, because of their complicated machines and you have to do a lot of maintenance. And as a result, you have to pay for that essentially on a per hour basis, is how we usually think about this. Um, I think that you can't really separate these things in a sense that the idea of having a machine, a type of aircraft that can actually do this vertical takeoff and landing mission, this air taxi mission, in a way that's acoustically much less intrusive, is one of the really fundamental enablers of the new form of mobility.
Hmm. You talked earlier about how it was almost not secondary, but a secondary benefit in a way that the technology that you landed on, not to use a pun, on a talk about air flight, but around, the electrification. And I'm wondering if, as you've looked at the industry, has that sort of technology first and sure, sustainable and with emissions in mind and things like that, but has that technology first sort of positioning helped you with investors and even on the regulatory front?
I mean, I think that it is it can sometimes a purity of mission in a way. Like we know like the product that we're trying to build, right? We've been working on this for a while, and we know the enabling technologies that we believe we do anyway. You know, we're still working on bringing it to market, but we've been working on this set of enabling technologies that we see the pathway to achieving the product that we're trying to build, and that's really been the focus. And so, you know, all of the efforts, all of the work that we've done toward this, I think it have been along those lines, right? And so I think that the all electric nature of it is really important. Don't get me wrong. I mean, I think that is really enabling of that mission. But it's really kind of comes out of the technology. It's like a new set of technologies that you can apply in this new and novel way. You could never build this aircraft. I mean, you could do it, but it just wouldn't be economically viable with traditional technology, because traditional motors and, you know, I don't actually, maybe it's not even possible in traditional, because you'd have to like cross shaft all these propellers together to try to like build redundancy mechanically into the whole thing, or you just have oodles and oodles of parts from traditional power plants. It doesn't really close. And so that's in some sense the power of the technology kind of arc that we're on, that we're trying to really develop on to make this new product possible, because of the advancements of these underlying technologies.
Yeah. Joby is also pursuing this gas turbine hybrid vertical takeoff and landing aircraft. That's a mouthful that can fly autonomously for defense applications. And why pursue, another powertrain, another fuel source, and even another application?
So we're building. I think it's part of like this the vision of the mission that we're trying to do, right? So we're building this set of foundation technologies, and the all electric air taxi, which is the primary thing that we're working on certifying, was the thing we're working on certifying in the primary path to market, is all of those technologies are necessary, and so we're working on that overall certification of this aircraft. So that means the batteries, the motors, the cables that connect these things together, like the way that the electricity and the network signals are distributed throughout the aircraft, the actuators, the electromechanical actuators that are different than anything else in the market. So we're building and certifying all of those parts. But then when we have that electric air taxi done, we have this set of like really advanced, extremely high performance certified parts that we can then do other things with, and like adding in another fuel source, whether it be a gas turbine or a fuel cell, like a hydrogen fuel cell, which we demonstrated last year, actually, about a little over a year ago, in some work that we were doing with the Air Force and under Agility Prime. It's actually like relatively easier than doing this whole thing from scratch. So, we're adding in one more component, and then opening up a new set of use cases potentially. And I think that that's pretty interesting, that we're able to take that foundational set of technologies and then, either extend capabilities, expand into a different market segment, but still leveraging that core set of things that we've been designing, building, and certifying all these years.
Well, that's like the interest. I'm sure investors were happy to see that, right? Because there's a diversification, but there's always that balance between not getting too distracted, right, from the central, project, and then these other things that you mentioned, you can kind of apply to. So, are there other applications that you're looking at or even thinking about, maybe even experimenting with beyond the defense application and sort of the core mission right now, which is that urban air taxi service?
We certainly have small teams looking at other future things, future extensions of this, whether or not it's future versions of the commercial air taxi that extend into different markets, or different things. And I think that if you look at things like the demonstration that we did with the hydrogen fuel cell, or this work that we're doing, and the demonstrations that we'll do with a turbine hybrid, it really, like, those are the proof of concepts in a sense, like very small efforts relative to the overall arc of what we're doing, and they point the way to potential product extensions of this in the civil space, as well as interesting applications in the defense space. And we're taking a hard look at all of those things as we build our future product roadmap.
I understand that these things could change, and you might get down the road on certain one of these and say that it's not the right time. But what to you are the most intriguing that have right at least right now that you're most excited about, or have some promise at like a very early stage of looking down these various other roads?
Well, I mean, I think that if you look at what we've done and talked about publicly, it kind of gives a good sense of that in a lot of ways. We actually brought in a couple of years ago a company called H2 Fly in Germany, which has done a lot of work on hydrogen fuel cell integration and flew kind of one of the first liquid hydrogen fueled small aircraft and demonstration flights a few years ago. That technology actually fueled and literally, but fueled the work we did last summer with the hydrogen fuel cell demonstrator that we flew down or out here in California. And then we brought in house a company called X-Wing last year that is working on certified autonomy and maybe more broadly autonomy. They had been working on applying autonomy to existing aircraft. We actually that work kind of resulted in something that we've talked about recently. They flew in an Air Force exercise called Refer Pack, showing essentially we flew thousands of miles remotely piloted, essentially, or remotely operated, I think is the better word, with our technology called Superpilot. We had a station in Guam, and the aircraft was flying over Hawaii. We had a safety pilot in it as part of that, but most of it was flown from Guam, basically. And so I think that there's interesting applications and extensions of that, and certainly those technologies we see the arc of how they come together, and in future iterations of our product enhance uh, the basic vision of the all electric air taxi and extend that into other things.
Yeah, I want to talk a little bit about autonomy and where Joby stands on that, because my understanding is that the urban air taxi, this is going to be piloted. But there has been, just now, there's been talk and conversation about eventually having some flights autonomous. And I know that there's, of course, the ones that you're applying to defense. But what is the specific approach to autonomous flight that Joby is taking and working on? And, what is the timeline for that?
Yeah, so we think autonomy is going to be a really important piece of the puzzle down the road. We made the decision early on that it was not the right thing to include in our initial certification because the regulatory frameworks really and still haven't yet, I think, evolved sufficiently for doing certified autonomy for a passenger carrying aircraft used in civil applications. And I think a lot of people are working on that. We continue that work that the X-Wing team has been doing, and that we're leveraging it into other segments as well. I think that's a really important piece of it, right? This is a highly regulated space, and so we have a lot of innovation in our all electric air taxi that we're driving into the market, and so we think that the fastest and best way to get to market is with a commercially rated pilot that will be flying these air taxis. I think that in the longer arc, there's certainly, I mean, autonomy is going to play a role here, whether or not it's in making the aircraft easier and easier to fly, faster and faster to train pilots to fly, um, or something else that's a bigger step change. I think that we'll see as both the regulations and the market evolves on this, but that it's something we're paying pretty close attention to, and again, with our work with X-Wing, actually doing quite a lot of technical work in the foundations.
So is it fair to say then that you are actively working on autonomous systems, but not certainly not in first product, but through your work with X-Wing and maybe in other ways that you are actively working on autonomous flight systems?
Yeah.
Or is this more like in the lab moment? It's not as taking as much time of the company.
No, we're certainly actively working on it. I think the demonstration that we did as part of that Refer Pack flights show that, right? That was active work that we were doing, and it kind of flowed out of the work that the X-Men team had been doing and has been continuing to do as they're part of Joby.
Mm. I know that there are a lot of companies out there that are specifically working on like automated flight or automated safety systems within the cockpit. And I'm wondering if there are any safety systems that Joby specifically has innovated on or has partnered with to sort of level up existing safety features that you see in a more traditional aircraft today.
Well, I mean, it's hard to separate that question out from the kind of fundamentals of the entire aircraft, really.
Yeah. Yeah.
I mean, this aircraft is architected differently than any traditional aircraft is, right? So we actually have essentially built fault tolerance across the propulsion system, across the computers, across the sensor suite. It's a fly-by-wire aircraft, and so in some sense it's wired for autonomy from the very beginning as well. Um, and except that we have pilots inside flying it, right? And so that's it's really hard to separate that out. I mean, we have a very distinct and very clear set of requirements that we've worked with the FAA to kind of refine and write down essentially, that's appropriate for this type of aircraft because they haven't certified one like this before, and we're driving hard against that and every day engineering the systems to meet that high bar that the FAA sets.
Yeah. Well, as I mentioned earlier on in the conversation, Joby has been around for about 16 years now. When Joby started, it was pretty small, pretty quiet. Today, it's quite different. A publicly traded company doing public work and doing public demonstrations, including recently in California. And I believe that Joby has done something more than 600 test flights this year of varying durations and distances. But not quite yet at that commercialization. So, here's my cheeky question. What's taking so long, Eric?
So, I mean, we are working through the FAA certification process, and it is a difficult process, and it's difficult for a reason, right? It's because there's a lot of T's to cross and I's to dot, and so someone asked me recently, like, what's the hardest part of this process, and I kind of said it's just like you have to do it. I mean, it's like you just have to do the hard work. That's part of what certifying an aircraft for civil application means. And that's part of kind of the what the public expects when we actually launch into service. And so, we've been doing all of that hard work. It means lots and lots of analysis and lots of testing, right? And we're in this phase where we are continuing to work with the FAA to, they have to review every test plan for every component of the aircraft that we have, and we're writing these test plans, and they're reviewing them. We submit them to them, and they finally approve them. And as they approve them, we're doing the tests. We've been doing tests before that because we, doing it to figure out like how we should write the test plans, right? So there's a lot of developmental testing that happens, but it has to be true for everything. Like the FAA this type certification process is effectively a design certification. It is, and so it's creating an audit trail from the very top level safety intent requirements that the FAA sets forth for this type of an aircraft, which is something, again, we had to work with them to figure out what that is. And that's that certification basis that's published actually was published in the Federal Register. And then translate that all the way down to what are the exact tests you're going to do, and did you have acceptable results on those tests to build this audit trail that the design down to the smallest bolt essentially in the design conforms and meets that requirement at that top level safety purpose. And only then can you build ones that you can actually then use for commercial use. So that process is very intensive on purpose. It's just the way civil certification is done.
Right. And I think that most people can agree that that is good, that it is an arduous process. My understanding is about 5 steps, right? Or 5 levels, I guess. And Joby right now is midway through the 4th step. Is that accurate?
Yeah, that's right. So we, the FAA has not. I mean, they have a published guidance on this whole process, and a lot of it. Then people who do it understand how to do it, right? So there's a lot of kind of experiential knowledge, I would say, as part of it. We because there's a lot of scrutiny on this process. There's a number of folks who are in this situation who are working towards certification of these types of aircraft, and I think there's probably more attention to the type certification process as a result of this than maybe there has been in the past. And so we decided to try to provide a more granular scorecard in a way for what we're doing, and try to so that we could talk about this on a regular basis in terms of the progress that we're making in this. So we broke it down into these 5 steps. They mapped to the the FAA's published guidance, but really they're auditable, and it's essentially based on things and documents that we're actually submitting and getting approved by the FAA. And so the step 4 that we're on of the certification process is this test plan submittal. So test plans, again, we're writing these detailed test plans, and for everything that we've agreed upon with the FAA that has to be tested, which is essentially all these components and subassemblies and assemblies, et cetera. And then we submit those test plans to the FAA and they accept them. And so we report both on our submittal. So how are we doing in terms of submitting the exact test plans to the FAA, and how are they doing on accepting those, because they have to review them and we go back and forth, and then eventually they accept the test plans that we submit. And so we're making great progress on that. I think well over 60% through that from a submittal standpoint from our last kind of public publication of those results, and the FAA was approaching, I think, 50%, 40 to 50% of the acceptance. So the exact numbers are published in our quarterly reports on that.
Got it. Well, it seems like a timeline then is kind of difficult to predict. Do you have any expectations of that? Because you're really at the mercy in a way, even though we can all agree that that's a good thing, at the federal government and their process. So do you have a sense of your timeline for the United States?
Yeah, so we are, you're right. That is not something that's fully within our control. I mean, what's in our control is like doing the work and getting it in front of the FAA as fast as possible, right? And so that's kind of the way we've architected everything that we do. So and then responding as quickly as possible when they have comments, and so that we can go back and forth. We're really driving toward a critical milestone, though. And so there's a thing called TIA, which you've probably heard other people talk about. We've been talking about it a lot. It's called a type inspection authorization. So really, this is a huge step in the admittedly somewhat opaque type certification process that we are driving toward. And this really means, so as we're writing those test plans, right, one of the sets of test plans we have to write are the flight test plans. So when you actually have the entire aircraft assembled, what are the flights we're going to do, the series of flights that we're going to do, flight tests, and then what are the expected outcomes of those flight tests that we're going to do to prove the different things that we have to prove regarding the performance of the airplane, different mechanical performances, et cetera, et cetera. And so the FAA actually has test pilots that will fly our aircraft and execute those agreed upon test plans. And that's called TIA, essentially. There's going to be a whole series of these test flights that will happen. And so we're driving toward the first of these important FAA piloted test flights in early next year is what we've been targeting for this. And so that's a really big gate that we were driving to get through. We see it as kind of entering the last lap, kind of the final lap of the type certification process in a way. From what we've looked at data wise, companies that enter that final lap, that get to the TIA step with the FAA, eventually finish. And so I don't think there's an example of a company not finishing the type certification process once you enter that final lap. So we think it's really it's a really big gate. It's not won't be done yet at that point, but it's a really important gate to get through that indicates the maturity of what we're building and shows that we're in that final lap to getting this type certification done.
First of all, I know that Joby is planning to actually go to Dubai first, and I'm wondering if that is still on track to start carrying passengers in Dubai in 2026.
Yeah, that's right. So what we've done is we've worked out an agreement with the two different agreements essentially in Dubai. So Dubai has a regulator for transportation, and actually that it's called the RTA, the Road Transport Authority. Traditionally, has been a kind of the taxi regulator, kind of the surface transportation regulator. Though they're actually have gotten the right to regulate the air taxis as well. And so we've been working really closely with them for a number of years now, and we'll be the air taxi provider for Dubai once we have our Dubai UAE kind of qualification and certification done. And so there's another entity that GCAA is called. So it's essentially the FAA for the UAE, which is a federal level regulator there. And so what we've done with them is taken the work we're doing with the FAA, and they're devoting extra resources for doing that final review step, which is kind of the step 5 you think of as the process, which is we have these test data that we've generated there, and then there's a subset that really matter for initial commercial operation. And you can think of cold weather testing, not so important in the UAE. It's kind of a good example of that, where they're going to be devoting extra resources to review the test results and get us essentially a provisional qualification to be able to start doing some commercial operations as quickly as we can finish that subset of tests and prove that this is everything is working exactly as we intended to work. And so that's really exciting. We've been working very very closely with them and are targeting starting to carry passengers in 26 under that framework.
And lastly, you've been involved in this industry for long before you were at Joby. You were ahead of Uber Elevate, and you're at Z Era, which holds an important place in the history of electric aircraft development for sure. Looking back to those early days and seeing where this still nascent industry is today, is right now where you expected the industry to be, or has it taken longer than you expected?
I mean, I was a grad student, essentially it's like fresh out of grad school, starting working on this back in 2010 at Z. So I don't know that my expectations of timeline were accurate, but it's probably a good thing, right? In a lot of ways that we get working on amazing innovations. And I think if I could see the attention, the amount of funding that's been brought into this industry, the attentions at the highest levels of the FAA, DOT, the overall uh, excitement, I think, and enthusiasm across the government for what it is that we're building here. And then I would say outside of the U.S. and the globally, the response. I mean, we have an aircraft in Osaka right now that's flying daily, multiple times per day with our partner ANA for the Osaka Expo. And we've got they have 100,000 plus people on a daily basis coming in to the expo, and I think our test pilots are kind of minor celebrities now in Japan as a result of these test flights that we're doing, and just seeing the enthusiasm, seeing the momentum that's building, seeing the the fact that this vision that we've been building toward over all these years has traction, and people want this to exist. It's amazing, and I would be. I wish that my younger self could have seen that then. It would have just had that much more enthusiasm and drive to make this happen.
Great. Well, thanks so much for joining us, Eric. And back to the SOSV Climate Tech Summit.
Thank you.